In this video, we're going to begin using our logarithmic properties to condense expressions. This is a necessary skill when we get to solving logarithmic equations. Okay, so in order to condense them, first thing you've got to look for is, do your logarithms have the same base? These are both base 7, and it's held by addition. So we are going to combine this into one logarithm, log base 7 of 9 times 4, and you could even make this log base 7 of 36. In 8, again, checking to make sure our logs have the same base, and they do, so I'm going to write this as one log with base 2, and my argument is going to be 80 divided by 5, because this is the quotient property, and you could, of course, reduce that to log base 2 of 16. And because we can, this is one we could easily figure out in our heads. Log base 2 of 16 is really saying 2 to what power is equal to 16, and hopefully you recognize that that would be 4. So 9, the directions say condense. So what I'm going to do is first take this 1/2 and use my power rule and bring it up to the argument to make this log base 3 of 81 to the 1/2. And 81 to the 1/2 is actually the square root of 81, which is 9. So we have log base 3 of 9, and let's see if we can figure out what that equals. This is really saying 3 to some power equals 9, and that would be 2. So this all equals 2. Okay, in 10, checking to make sure that I have the same base. They're both base 4. I can begin by using the power rule to make this log base 4 of 8 cubed minus log base 4 of 2 to the 5th. So this would then become, combining it into 1, log base 4 of, the argument could be combined using the quotient rule, 8 cubed over 2 to the 5th. Now, that I can simplify this argument, I could expand 8 cubed and 2 to the 5th. I could also actually, hopefully I don't lose you here, I recognize that 8, I could rewrite that with a base of 8 is 2 to the 3rd. So what I'd actually have is 2 to the 3rd right there in the top over 2 to the 5th. And then I can really have a lot of exponent rules I can use here. So it's actually 2 to the 9th over 2 to the 5th, which is, keep your base, subtract your exponents, 2 to the 4th. So now I have log base 4 of 2 to the 4th. Or log base 4 of 16. So 4 to what power is 16? That's going to be 2. Now, if your brain wouldn't have gone to make the 8 be a base of 2, you could have also just done log base 4 of 8 cubed is 512 over 2 to the 5th is 32, and then you could have reduced this. And that's going to end up getting you the same answer, because 512 divided by 32 is 16. So I think most of you would probably choose to go that route, and that's fine. Okay, now we've got one with the natural log, so base is e on all of these. And so I'm going to be able to combine this all into one. I'd start by actually moving that 2 up here to make this 3 squared, and 3 squared is 9. So this would be the ln of 9 right here. So I would have, first part would still be the same. So now I have addition and then subtraction. So I'm going to write this as 1 ln. It would be, the argument would be 27 times 4 divided by 9. And I think we can clean that up. This would be 27 times 4 over 9 will become the ln of 12. And that's not a nice one that I know, but that's as simple as I can get it. You could toss it in your calculator and get a decimal approximation on that one. Okay, now they're getting more complicated, but I hope you are weirdly enjoying it. So what do I see? We have all the same base here, and my second two logs are in parentheses, and we're going to try to condense this into one log. So let's start by bringing this 2 up as an exponent on that base. So that would be a b squared here, and then I will just scribble out that 2, it's gone. Okay, so what's inside would be log base 3 of, now it's going to, the argument would be held by division, because this is your quotient property, a to the 4th over b squared. And then I still have this first part that was out front. Okay, so again, still have same bases. So I'm going to combine this yet again into log base 3, and it would be a to the 7th times this argument, which is actually going to be, I can multiply my numerators, a to the 7 plus 4 would be 11 over b squared. See if you can try 14. Check the answer when you are ready. So this first part becomes log base 6 of 9, because you'd have 45 divided by 5 as your argument. Then I would bring this 1/2 up to make it log base 6 of 9 to the 1/2, which would be 3. So I have log base 6 of 3, and then I still have this other one plus log base 6 of 12, which would become log base 6 of 36, and then 6 to what power equals 36? It would be 2.